All right, I'm going to go over how to do some of the subnetting stuff. I've had a few questions and I want to go back over that and just put it in a video. That way you have it. If we think of the range of numbers in a Class C example, or any octet, but specifically a Class C, if we think of the range of numbers as a big circle, and it starts at 0 and goes all the way around to 255, and we realize that's all the numbers that we have, this is kind of what it would look like. So as we go through, I want to look at this example of a Class C and show you how borrowing bits from the host part of the address affects how we divide up these numbers. So in this case, I've got a Class C address. I know that from the first number. This is 192.130.223.0. I have a broadcast address. The .0 is the ID number for the network. The broadcast address is .255. It's the last number in the network. And then here's the subnet mask, which tells us how the address is split up. The first 3 octets of the network part, the last octet in the mask shows us that's the host part. And that's why these numbers are constantly changing and these numbers never do, because the first 3 sections are the network part of the address, the last section is the host part. So the host part is what we're going to be working with. And this is simply expressing 0 in binary. So we have 8 bits, 8 binary bits that represent the 1 decimal number. That's what we're looking at right there. Here's our Power 2 chart. We'll be referencing it along the way. And what we have right now is we have in the subnet mask 8 zeros in binary. Okay, so what that means is we have not borrowed any bits at all. So we have a full 8 binary bits as zeros in the subnet mask. Okay, so that's how we need to look at this. This is the decimal version. This is the binary. So there's 8 of them. Since there's 8 binary zeros in the mask, that's going to give us, if we look at our Power 2 chart, 2 to the 8th power is 256 numbers, okay, which is 0 through 255. So to do the math on how this works, just to understand the process, what we always do is we take whatever the mask is in decimal and we subtract it from the broadcast address of the unsubnetted IP address. So what that does is it says 255 minus 0 in this case gives us a number of 255, which means we're simply going to have a range that begins at 0 and ends at 255, which is 256 total numbers. So again, 8 zeros, 256 numbers. We've not borrowed any bits, so that's why we have 1 network. So no 1 bits in the mask, and as far as the host part goes. 0 ones means 1, or yeah, 0 ones means 1 network, 2 to the 0 power because we have not borrowed any bits. Okay? That leaves us with 1 network of 256 hosts. Again, 0 being the first number. There's where our 256 comes from. So again, that mathematical equation is you take whatever the mask is in the host part, convert it to decimal, subtract that number from the broadcast address, and that tells you what your range stops at. In this case is the entire range. 8 zeros, 256 hosts. There's no 1s in the host part of the mask, therefore we have 1 network. Now, if we borrow one of those bits, that changes things. So when we take one of our host bits and make it a 1, that turns the value into 128. What one bit does in the mask, 2 to the first power, means we're going to have two sections of our numbers, or two networks. Okay, so just look at how the math works out. One binary bit to the first power means we have two networks. And we have 7 zeros left over. So we're going to see we're going to have 128 host addresses in each one of the two networks. So we got to figure out where these numbers start and stop so we can figure out what our ranges are. To do that, again, we take the new mask, the modified mask, and we subtract it from the original broadcast address. That gives us a number. That number is the last number of the first range. So it stops at 127, which means the next range begins at the next number in the cycle. So we have two ranges. One of them begins with 0, it goes through 127, which is a total of 128 numbers. The next range begins with 128 and stops at 255 because that's where the numbers stop. We still began with 0 up here. We ended with 255, but we now have two ranges, again, because we've borrowed one bit. To the first power is two networks. And we have 7 zeros left in the mask, which means we have 128 hosts per the two networks. That's how this math is going to work. Okay, let's look at another example. We have 2 bits here. So if we borrow 2 bits, to the second power is 4. So what we're going to have over here are 4 networks. And notice these numbers don't change as we progress through this process. 0 will always be here, 127 will always be here, 128 will always be here, 255 will always be here. We just now need to figure out what are these other numbers that stop and start now the 4 ranges. So if we convert this to decimal, 192, we apply it over here, we subtract 192 from the broadcast address, that gives us a number of 63. So there are going to be 64 rather, numbers in the network. 0 through 63 is 64 numbers. How many zeros are in the mask? Well, there's 6 to the 6th power of 64. So that's where all this is coming from. And what we have here are 4 ranges. There's our 1, 2, 3, 4. We start with 0, end with 255. We just got to figure out where all the starting and stopping points are along the way. So if we apply the 63 here, that's the stopping point of the first range. We know the next range begins with 64. Now, where does it stop? Well, we already know that number. It stops at 127 because that number is never going to change. So we just put 127 there. We already know the starting point of the next range is 128. And now we just have to figure out this. Now, if we learn our little trick that the last range always begins with the new decimal value of the modified subnet mask, that means that number is going to become 192 because that's just how it always works out. The last range is always starts with this value, whatever it is, of the subnet mask. So if this is 192, which it is, that means this range has to stop at 191. So there's our 4 ranges. Each range is going to have 64 total numbers in there. So 4 networks, there they are. Each network is going to have, because we have 6 zeros left in the mask, each of those 4 are going to have 64 hosts per each 4 of the networks. All right, let's go one step further. 3 bits. If we borrow 3 bits, we can already kind of look. We're going to end up with 8 networks. Each network is going to have 32 hosts because there's 5 zeros to the 5th power. There's 3 ones to the 3rd power. That's what we're looking for. And we got to convert this to decimal to do all of our math. So convert that, you get 224. Again, we're going to have 8 ranges. So all these numbers are going to stay the same on our chart. We're just going to subdivide those and divide them in half again. Okay. We put our mask over here, 224, subtract that from the broadcast address, that gives us a number of 31. This tells us our first range is going to stop at 31. So we have 0 to 31. Then we have some number, and then it's going to stop at 63. We already know a lot of these numbers because we've already worked it out in the other example. And those, again, will not ever change. So if we got to figure this out, the next number above 31 is simply 32. That's easy. We already know it's going to stop at 63. The next range begins at 64 because it's already right here. So how do we figure out this number? Well, we add the magic number of 31 to 64, and that's going to give us 95. We then know the next number to start this 4th range is going to be the next available number, which is 96. We already know 127 and 128 from prior processing. Okay, so we add 31 to 128, we get 159. That tells us this is going to be 160 because that's the next number in this range. We already know these two numbers. And again, if you do your trick, 224 is going to be the number that begins the last range. So this is going to be 223. There you go. There's your 8 ranges. 3 ones in the mask means 8 ranges. There's our 8 ranges. 5 zeros left over means we have 32 numbers per each of the 8 ranges. All right, it's going to get a little crazy this time. We go through and borrow another bit. We borrow 4 bits. 2 to the 4th power is 16, which means we have 16 networks and 16 hosts per network. This is what the numbers would look like if we applied this mask of 240, which is 1, 1, 1, 1, and the rest zeros. And we subtract 240 from 255, that gives us the 15. So 0 to 15, 16 to 32, 16 to 31, 32 to 47, 48, 63, and so on and so forth. We start at 0, stop at 255. And it's just going to subdivide all these in half again. And how are we going to have? We're going to have 4 bits as ones, therefore there's 16 networks. And we're going to have 4 bits as zeros, so each of the 16 networks will have 16 computers. Pretty cool. Now, if we do it again, borrow 1 more bit, that makes this a value of 248. And we're going to have 5 bits as ones and 3 bits as zeros. We're going to start seeing these numbers shifting around a little bit. It's going to get quite chaotic over here. And I've omitted some of the range just for space sake. But your numbers are going to be now 0 to 7 because 248 subtracted from 255 is 7. So this first range will be 0 to 7, then 8 to 15, 16 to 23, 22 to 31, 32 to 39, and so on and so forth. 5 ones in the mask means 32 networks total. 3 zeros in the mask means 8 hosts per each one of the 32 networks. And if we borrow 1 more, we'll just go all the way through it. Now we're borrowing 6 bits. Go ahead and predict. We're going to have, 64 networks, 2 bits left. So we'll have 4 numbers per network. And that's the way it works out. This is a value of 252. Subtract 252 from 255, we get 3. 0 through 3 is indeed 4 numbers. 2 zeros to the 2nd power, 4 numbers. 6 ones to the 6th power, 64 ranges. Okay, so 64 networks, 4 hosts per network. Now, if we do it one more time, and this is theoretical because this really doesn't work, but this is how it would turn out if we did this. If we borrowed 7 bits, we're going to have 128 networks, 1 0 to the first power, because 1 0 means we have 2 numbers per range, 0 to 1, 2 to 3, 4 to 5, 6 to 7. Now we end up losing all of these as available numbers because of a -2 rule, and we'll talk about that later. Okay, but the -2 rule says you lose the first and the last number for ID reasons for the network and subnetworks, and broadcast reasons for the networks and subnetworks. I'll go ahead and talk about it now. So when we first started, 0 is considered an ID number. That's the first number in the range. 255 is considered a broadcast address where you can send it to everybody in the network at once. First number is lost. Last number is non-assignable. Same thing with the subnetworks. First number, you can't use it because it's an ID number now. Dot 0 is subnet 0's ID number. Dot 2 would be subnet 1's ID number. Dot 4 would be subnet 2's ID number, and so on and so forth. These columns, this represents the broadcast numbers. So those are not assignable either. So in this case, you've lost all your numbers. So you would never borrow 7 bits. But just to show you how the numbers work out, that's what it would look like. Again, in this case, we have 7 bits as ones in the subnet mask, which means 128 ranges. And each one of those ranges has 2 hosts per network, which again doesn't help us any because we lose them both due to ID and broadcast reasons, but we'll talk more about that in another video. All right, that's it for now. We'll see you guys later.